In this video, we are going to talk about a quotient rule. Up until now, we haven't been able to take the derivative of a function divided by a function. But there is a rule for that. And both the quotient rule and the product rule actually come from that limit definition of a derivative. I'm not going to derive them in this video. They do it in your textbook. And if you have questions on that, let me know. So, the quotient rule, what does it say? With the quotient, you have to have a top function and a bottom function. So they're calling the top function t of x and the bottom function b of x. And the quotient rule says the derivative of the quotient will be the bottom times derivative of the top minus top times derivative of the bottom all over the bottom squared. So let's work through a few examples. In 29, we have a rational function. F of x equals x squared plus 2 over x squared minus 3. So our top function is that numerator x squared plus 2, and the bottom function is the denominator x squared minus 3. So our derivative, and I'm going to use that prime notation in that first step. This is the setup. I am not taking the derivative yet. The quotient rule says bottom times derivative of the top. So I'm using the prime notation to show I need to take that derivative. Minus the top times the derivative of the bottom all over the bottom squared. Now, I want you to notice parentheses. My top function has two terms. I put parentheses around it. The bottom function has two terms. I put parentheses around it. You have to keep parentheses so you can show that you're going to end up distributing at some point. So now let's go in and take derivatives. The derivative of x squared plus 2 is 2x. The derivative of x squared minus 3 is also 2x. I'm going to distribute here. That's going to give me 2x cubed minus 6x. And then I'm going to distribute here. 2x cubed plus 4x. Notice I kept that in parentheses because all of that will be affected by that minus. So I have 2x cubed minus 6x minus 2x cubed minus 4x. All over x squared plus x squared minus 3 quantity squared. So notice this is going to reduce. Those two terms cancel. And then I can combine the negative 6x minus 4x to give me a negative 10x. So my derivative for this function is negative 10x over x squared minus 3 quantity squared. Let's do another one. In 31, we have another rational, sort of a rational function. We have e to the x in the numerator, and then x squared plus 1 in the denominator. So let's take the derivative. And this is where you may want to pause the video, try it yourself, and then come back and check your answer. Quotient rule says it's the bottom times the derivative of the top. I am not taking the derivative yet. I'm doing my setup. Minus the top times the derivative of the bottom over the bottom squared. So now I've got it set up. Let's take the derivatives we need to take. Derivative of e to the x is e to the x. The derivative of x squared plus 1 is 2x. So I have e to the x times x squared plus e to the x minus 2e to the x times x all over x squared plus 1 quantity squared. And we could factor in e to the x out of each of those terms. We actually could have seen that here also. That's going to leave us with x squared plus 1 minus 2x. And that's going to end up factoring also. I'm just going to do a rewrite. We're used to seeing quadratics with exponents in descending order. And now we see that numerator factors into x minus 1 times x minus 1, which is x minus 1 squared over x squared plus 1 squared. Let's do another one. In 32, we have the function f of x equals 1 minus e to the x over 1 plus e to the x. This is a quotient rule problem, so it's bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. Notice I have not taken the derivative of anything yet. That's my setup. Now let's take the derivatives. The derivative of 1 minus e to the x is minus e to the x. The derivative of 1 plus e to the x is positive e to the x. And then if we do some fancy math in the top, we're going to distribute here and here. We have minus e to the x. And then we have e to the x times negative e to the x. Well, we know a positive times a negative is a negative. And when we multiply and we have the same base, we add those exponents together. So my new exponent is going to be 2x. Minus. And now we're going to distribute this e to the x to that 1 minus e to the x. 1 times e to the x is e to the x. And then now we have a negative e to the x times e to the x. Negative times a positive is a negative. When we multiply and we have the same base, we add those exponents together. So that becomes an e to the 2x over 1 plus e to the x quantity squared. Let's distribute this negative. So we're going to have minus e to the x plus e to the 2x in the numerator. And you can see how that's going to simplify. Those e to the 2x terms cancel. So our final answer will be minus 2e to the x over 1 plus e to the x quantity squared. And let's do another one, 33. So in 33, they are asking us to find the derivative of ln of x over 1 plus x. So let's take that derivative. Quotient rule says it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So there's my setup. I have not taken a derivative yet. In the next step, I'm going to take derivatives. The derivative of ln of x is 1 over x. The derivative of 1 plus x is 1. So if I distribute this 1 over x to everything in the top, in that parentheses, I'm going to have 1 over x plus x over x, which is 1, and then minus ln of x. And all of that's over 1 plus x quantity squared. Now, notice we have a complex fraction here, and we have a fraction in the top of the bigger fraction. So we do want to simplify that. The easiest way to simplify that is going to be to multiply that big fraction, top and bottom, by that least common denominator. In this case, it would be x. As long as you do the same thing to the top and the bottom of a fraction, it doesn't, it's a legal move. It doesn't change the original. So if I distribute, I have x times 1 over x, which is 1, plus 1 times x is x, minus x times ln of x. And all of that is over x times 1 plus x quantity squared. So there's our derivative. So let's go back and let's work 38. In 38, we want to find h prime of x, where f of x is an unspecified differentiable function. So let's set up that quotient rule. Quotient rule says it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, I have not taken the derivative of any function yet. That is my setup. So now let's take derivatives. The derivative of f of x is f prime of x. The derivative of x is 1. And I'm just going to simplify. I have x times f prime of x minus f of x. And all of that is over x squared. So there is our derivative. And then let's do one more problem where we have to find the equation of a tangent line, 65. We have f of x equals x over 2 to the x. And this is where you may want to pause the video, try it, and then come back and check your answer. To find the equation of a tangent line, you have to have a slope and you have to have a point. So to find the slope, we first have to find the derivative. So it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So there's my setup. Now let's take derivatives. The derivative of x is 1. The derivative of 2 to the x is 2 to the x times the ln of 2. And I'm going to have all of that over 2 to the x quantity squared. So if you notice, there's a 2 to the x in both of the terms up here in the numerator. So I'm just going to factor that out. And that's going to leave me with a 1 minus x ln of 2. And that's going to be over 2 to the x quantity squared. And now you can see I can reduce those 2 to the x's. So my derivative is 1 minus x ln of 2 divided by 2 to the x. Now we need the derivative to find the slope. We're looking for the slope of the line at x equals 2. So if we substitute a 2 in here, we have 1 minus 2 ln of 2 divided by 2 to the 2, which is 1 minus 2 ln of 2 divided by 4. So it's not a nice slope, but it is a slope. Now we need to find the y-coordinate. To find the y-coordinate, we're going to substitute that x value into the original function. So we're going to have 2 over 2 squared. So that's 2 over 4, which is a half. And then we're going to have y minus y1 equals m times x minus x1. So we have y minus 1/2 equals our slope. Times x minus x1, which is 2. So I'm going to distribute this number. We're going to have 1 minus 2 ln of 2 divided by 4x minus, and then now we're going to have this number times 2. Let me write it this way. So it's 2 times 1 minus 2 ln of 2 over 4. You can see how that 2 and that 4 is going to reduce. I'm going to copy this to the next page. So we have y minus 1/2 equals our slope, which is 1 minus 2 ln of 2 divided by 4x minus 1 minus 2 ln of 2 divided by 2. And then we're going to add 1/2 to both sides. And then we're going to do some simplifying. So we have minus 1 over 2. So I'm working with this now. Here's the way I see it. I have a fraction here that's all being subtracted because of that minus there. I'm going to split that numerator. So I have 1/2 minus 2 ln of 2 divided by 2 there. And then I just added 1/2 to both sides. So if I distribute this negative into this parentheses, I'm going to have a minus 1/2 and then plus ln of 2. Notice that this reduces because I have a 2 in the top and the bottom. And then I still have this positive 1/2 hanging out. And notice those are going to reduce. So my equation of the tangent line is going to reduce to this guy. So y equals 1 minus 2 ln of 2, all that's over 4. That's your slope, times x plus the ln of 2. There's the equation of the tangent line.